Everyone, I would like to welcome you back to another KevCAM night class tonight. Tonight, have Greg Payton helping out with any questions or anything that I miss along the way for you guys. Greg, you with us?
Hello, everybody.
It's been a while since we had him on the class, so it's good to have him back in the office and helping out. But so tonight we are going to be covering 3D contour. I do see a couple new names in here, so we do these night classes every Tuesday night. It's on a subject of whatever you guys would like to see. We definitely like to have your input and on something maybe that you would like to see. So send me your ideas via email and we'll get those implemented in for you. And everybody is in mute just to eliminate any background noise. Especially at Ronnie's house, it gets pretty chaotic there, so we have to definitely put him on mute. But any questions come in, definitely put them in the questions panel and we'll answer them right away for you. Very laid back class for you guys. And so with that being said, we'll get the ball rolling. One thing I did forget is for everyone that is new, all the night classes are recorded. We've been doing this, Greg, what has it been, 4 years now?
Yes, it's really adding up.
Yeah, so you guys can go over to SolidCAM University and all the night classes are in here, as well as tip of the days, as well as quick little 5-minute, 10-minute long videos for you. So if you guys are looking for a video, just hit the little search icon here. And if you can't find it, let me know because we will definitely make a video for you on that one. But all right, so we'll get the ball rolling here with Contour 3D. And what Contour 3D is if you basically think of it as a profile operation, but with the Contour 3D is going to adapt for Z levels. So it will go up and down in Z depending on your chain, where on profile, when you go to define your geometry, it doesn't matter if you go up, down, it just brings it all up onto one plane, where, like I said, in Contour 3D, it's going to follow the exact contour of the surface. And I'll kind of show you an example of that. So what I'll do first is I'll show you a basic profile operation. And we'll just whip through this real quick here, because we covered this one last week. And do our tangent propagation here, accept that. Now, levels is, where is the deepest spot I want to go? So right now it's telling me I want to go 150 millimeters deep. But what actually happens is as we're coming around this side, we're going to be cutting air as well as up on here. So if we go to our technology, do a step down of 50 millimeters here. That's actually way too big. If we're cutting harder material, let me get a side shot here. And you'll see that we're actually cutting air on this entire front side here. So what we can do to change that is we can use the Contour 3D. So our Z depth is actually following along with the top geometry. So let's go ahead and do a Contour 3D here. And I'll grab that exact same geometry as what I just used. And we'll use the same tool. And levels I don't have to worry about now. And now if I go to, we're going to do left, and we'll do finish, and we'll do our same 5 millimeter step down here. And I do have to grab my level changed on me once I've switched it over from center to left. Step down 5. So now, if I minimize this, you'll see that our toolpath is automatically following the contour along with our Z level. along with over here, following all along. So now we are no longer doing any air cutting at all. So where this comes in real handy is if we had some material that we're hanging on to, like with a vise over here, it would come up and over that, so we're not going straight across and wiping out our vise as well. So like I said, it's a very simplified profile operation that just is following along in the Z for you as well. So another way we can go ahead and take advantage of this is on this radius that we have going along the bottom right here. So a lot of you, normally what we would do is use maybe like an HSS operation and come in there with a ball end mill. But for those of you guys that don't have that option or just want to go with a very simplified version to machine out our radius there, we can use our Contour 3D again. And I'm just going to kind of zoom in here and grab my chains. Okay, so that's the area that we want to cut. Now, since I grabbed that line right there, I can actually set my tool side to be center. But first, let's go ahead and grab our ball end mill here. And we're already set on center. And it automatically, when we're on center, has it defaulted to automatically do a floor finish for us. And we can either do tip of our tool, or we can actually do center of our tool. And the center is going to go to the center of our end mill right here, where on tip, since we're using a ball end mill, we want to use at the bottom of the ball. Or if we were using a square end mill, it would just go right off the exact square points there. So for this, let's go ahead and save and calculate here. And we'll do a simulate. And that ball end mill will follow right along our outside perimeter. Now you'll notice that I don't have any stock on here, and this is something, if we're just doing some rework or some cleanup stuff, you guys can actually pick your target as your stock as well, which that way you don't have to create any custom stock or just do a standard box model to do that. Now, one thing I don't like about with this particular tool is my tool is being shown as white. So what I'm going to do is change that over to an orange here. Now, when I do save and calculate, you'll see my orange, or my tool path is lit up as orange, as well as when I go to simulate it, anything that is cutting will show up as orange instead of white. And this little patch that's missing right here is just a tolerancing, but you can see we're really getting that material out of there right now. I don't get too lost with my space mouse here. Okay, so that is using kind of geometry that way. Now, another great way to use Contour 3D is if we want to deburr this part. Now, deburring parts on a prismatic part, straight floors, straight walls, all that stuff works great. But when we have an arc in here, anything going up and down is where that really throws us for a loop. So we have that option inside of the Contour 3D as well. Like I said, just think of Contour 3D as a profile operation, but basically just goes up and down. So I'll just grab my same geometry, because basically what I do is throw a chamfer around the outside of my part here. I'll go ahead and grab a chamfer tool. And you guys can use spot drill, taper mills. Myself, I used to work a lot with aluminum, so we would just always use spot drills. But like I said, definitely take your pick on what you would like there. This one, I'm just using a 16mm spot drill. Levels, what I'm going to do is once I go to technology, and then I want to set my tool side to be left, and I want to turn on my chamfer option. Now, if I go back to my levels, I can tell it how deep of a chamfer I would like to go. So right here, I would just like a 1mm chamfer, something a little bit of an edge break. And when I choose this chamfer option, you'll see that a tab automatically appeared up here. And this is to control the tool dynamics of the chamfer. So if I wanted to work on the very tip, I can put a very small number in there, or if I would like to work on a larger portion of my cutting diameter, I can put that in there as well. So I'll just do 1mm for right now. And by telling it that we want to go have a 1mm chamfer, it's automatically going to do the trig for you to figure out how deep to go and how far to step in to accommodate that 1mm chamfer. I may have to do more than 1mm here. Oh.
You have to give it a finish pass.
Sorry, good call. All right, so now we're coming in here. And we have a chamfer going all the way around our part now. So any questions with the chamfer? Not, like I said, not much in here. You know, we're using tool side left. We're telling it to do one finish pass, doing a chamfer with using the cutting diameter of 10mm. Now, if I wanted to use more of a tip, like I said, we can use 1mm here. Simulate this. Now if I zoom in here, you'll see that we're working more on the tip versus the larger diameter. And this comes in handy if we're kind of working against a wall right here. I can tell it to use more of the larger diameter to keep that shank away from a wall or anything like that. But this feature works really good for doing chamfer on more of a 3D part. Now what we can do is, since basically we are, I want to chamfer this inside slot right here as well, I can use that exact same operation. Now, before I actually jump to that, you'll see that my chamfer is starting right on a corner here. You guys can come in there and change that. So if I go to geometry, and this is kind of going back to the profile side, but we can just hover or get your mouse cursor in this field right on the start position field, and I can just click anywhere I would like, and it's going to change to that new location that I clicked on. So now we're starting right here, doing a lead in, lead off. So now we'll do the exact same thing with chamfering this inside one. I'll do a save and copy. Because I already have my tool set up, I have my levels already set up. The only thing I really want to change is my geometry. So I can grab new geometry here. Okay. And actually, I'm going to reverse this. Oh, wait, no, I should have left that. That's right, we can do that right in technology. I'll switch this back. Reverse. That looks good. And then I'll do the same thing here. I want it to start somewhere where it's going to be flat. and we already have our chamfer set. If I go to my levels, I have my chamfer depth set at my 1 millimeter. And as well, since I did a save and copy, it carried over my cutting diameter of 1 millimeter. So I can save and calculate this here. And you'll see we have a nice chamfer going all the way around our entire part there. So let's take a peek real quick, and I'm going to check out my setup real quick. Very important that you guys have a setup for each MAC position. And we're running this one on the Haas UMC, and you'll see that my part is actually inside my 4-axis here, so I'm going to raise that up. Looks good. So now we can simulate this with full machine sim. Now if I kind of hop in here. So this is that profile operation. So you can see that we're actually cutting air this entire loop all the way around. So go ahead and speed this up here. Versus here's the 3D contour. Okay, like watching paint dry there. So now we're coming in with our ball end mill. Going around, putting our radius in there, doing our chamfer and our chamfer. And we have a finished part. Now, I know this is a pretty short night class for everyone, which is not normal, but that's about it for 3D contour. Not a whole lot in there, or not a whole lot to show off. Greg, can you think of anything offhand that should let our customers know about?
No, I think you covered everything quite nicely. The one thing that I would mention is when you're looking at whether you're driving it by the tip of the tool or by the center of the tool, just keep in mind, if you're driving off the center, SolidCAM is not going to compensate for any interference that you may have with the tool to the tool path. So if your tool, the flat of your tool is going to gouge into your geometry line, that may come up. So definitely keep an eye on your tool path and your simulations when you're using the center radio button under the tool reference.
Yeah, that's a great point.
Yeah, other than that, I think that covers 3D contour quite sufficiently.
Let me show you guys what
I think everybody else thinks the same way because no questions in the questions panel.
So what Greg is kind of talking about, if we go off of center versus tip, is the center is going to be going in there, and it's kind of hard to represent it. Let me see if I can get this tool. Come on, tool, work with me here. I'm going to try to show you guys, but as it's coming down like this edge right here, if we were on center, that back side, so here's kind of on center, that back side would be cutting in to the model. And since we're using Contour 3D, it doesn't know that it's gouging. Well, it knows that it's gouging in there, but it doesn't see it as like HSS or anything like that, because we're basically telling it that we want to drive it off of that center of that tool and following that line. So that's kind of what Greg was getting at with would be gouging into your material, or vice versa. If you were coming up here, you could see that it would be gouging in using the center of that tool versus on the tip where it would just be working on the tip, working its way around. So,
and you can do the same thing if you're looking at the reverse of that as well. If you find yourself doing a 3D contour on, let's say, an interior pocket, and you see some moves that do not follow the geometry exactly when you're using the tip as the tool reference, that is because SolidCAM is automatically adjusting that tool to keep it from gouging. So if you don't care about how perfect it is following the tool edge to the geometry, and you just want to break that edge, and it could be fatter in places based off of your chamfer tool, then you can switch it over the center. That way it's following that exact geometry with the tip of that tool.
Yeah, great point.
So yeah, definitely take a look at the simulations and just see exactly what you're going to get. But yeah, a very useful tool.
Absolutely. Any other questions? All right, I don't see anything coming through, and like I said, tonight was a shorter class, just not much covering there, but next week we are going to be covering, I have to look just to, for myself here, see if you guys go to webinars, night classes, pocketing. So we will go through everything there is to know about pocketing, every little option. I'm giving you guys several different examples of kind of how the pocketing works, how you guys can use it, how you can manipulate the pocketing to do other things as well. So look forward to that next week. And with that being said, just want to thank everyone for attending the night class tonight, and we will see you guys next week. All right, everyone, have a great night.
Good evening.